In this video, I'm going to teach you about entity model interfaces. So let me begin by giving you a little background as to why this is such an important issue. Flames-based scenarios are extremely composable, and the composition is specified primarily in two ways. The first is by specifying which particular DLLs you want to load when a Flames application starts. So you can load any set of components that you want in Flames by just choosing different sets of DLLs. But the DLLs are loaded and initialized in a manner that is composition independent. The way those classes in those DLLs are actually used in the scenario is not specified by the classes themselves. It's specified through input data. So an end user who's building the scenario and just entering data, not a programmer, not changing any code, it's that end user that actually determines which particular models get attached to which units in the scenario in which combination. And we call that the composition of the unit. So what I have in front of me right here is one of the units in this Flame scenario, and it's got, I think, roughly 15 different models attached to it. And this composition of this unit was specified through input data. It's not specified in the code. So there's a potential for a couple of problems right here. One, all of which would stem from the user not putting the right set of models on here. And there's two issues that we have to deal with. First of all, for the developers who wrote the code for these models, how will they know once the scenario starts executing that the other models that they need to have attached to this unit are actually there, so that this unit has been composed correctly so that the models are going to work? So that's the first thing. The models themselves have to be able to look at each other and figure out if they're able to talk to each other. And the second issue is if the end user who's building this scenario happens to specify a composition of models right here, how will the user know that the composition is incorrect? In order for a system to be truly composable, the system has to tell the one that is deciding on the composition whether or not the composition is correct. And you want to tell the user when the user is specifying the composition. You don't want to wait until after the scenario starts executing and then some point during execution find out that the composition is wrong and generate messages. So the user might start up a batch run it overnight, comes in the morning and finds out in the log there's a whole bunch of error messages because he hadn't composed the scenario correctly and the run is invalid and wasted a lot of time. You want to tell the user right away if there is a problem with the composition. So I have switched here to another scenario that is used in the tutorial models. And I have a couple of meta objects defined that are based on that are instances of the tutorial model. So one of them is this FEX radar. And let me go and show you, well, first let me just show you what happens from the user interface if I specify a data processor that's not the data processor that this particular radar model requires. So this is one of the places where we're composing a particular player. We're building a model that is actually a composed of multiple models. So this radar model has an antenna and a data processor, and the end user gets to pick which antenna and which data processor I want to use for this particular sensor. And this sensor is expecting the other models that are entered here to support a particular interface. So I'm going to open up the data processor window, and I've defined not only the blue tracker for this example, but I've also defined another data processor called RWR data processor. That stands for radar warning receiver. So one of these is of this class, the FEX tracker class, and the other one is the FQD simple RWRDP. So I'm going to go over here to this window right here, grab this name, copy it, go to the sensors window, paste the value in right here, and I'm going to hit accept. And I get this message. The specified data processor does not support the FTrack data processor interface. Entity configuration failed, accept changes anyway. So I'm going to say no, I don't want to do that. So there's an example, one example of a common place where interfaces, where a composition is specified by the end user. I'm the end user. I decide to attach this kind of radar data processor to this sensor. I put in a legitimate data processor in the sense that it actually really does exist, but I put in one that doesn't support a particular interface. So immediately the user got feedback. I got feedback that said, this isn't going to work. So this, if I did accept the changes to this radar warning receiver or this radar, it would be flagged as not having passed configuration, and it would not be allowed to be attached to a unit. So the user isn't even going to be able to use it in a scenario. So let's go look at another place. So I'm going to click that back, and I'm not going to keep that composition. The other place where composition gets specified is in script. And this is where we get to very flexibly specify which particular models we want attached to the unit. So I'm going to create a data set and create a new unit and hit accept. So there's my unit. I'm going to go over to the script tab, and I'm going to attach a platform to this unit. So I use the employ statement, employ platform, and then I can browse for the platforms that are in my scenario. So I'm going to pick the red truck, put a semicolon after that, and so it's fine. So you can see in my composition, there's my red truck. So now I'm going to employ a cognition model on this unit. So I'm going to say employ and cognition. And then I'm going to browse for one of my cognition model meta objects. So I'm going to put this ground vehicle driver on this unit and hit accept. So now I go to the composition. You can see I've got two models that are attached to this unit. And I didn't get any error messages, so I have reason to believe that these two models are compatible with each other. Well, what happens if I go in here and I'm just going to comment this out, and I'm going to hit accept. So I get an error message. It says, no platform is employed that supports the FG vehicle platform interface. The FEX driver cognition model will not execute for this unit. And then it says error executing this particular command, when this is the command that made these tests. So no, I don't want to accept these changes. But so here's a place where I'm putting individual models one at a time on a unit. This is a cognition model that drives a platform model, controls a platform model. So this is the human driver of a platform model. Without a platform model, this guy says, well, I can't drive. I don't have a platform model here. So I'll say no. So these are two places, two examples where models are able to go look at the other models, either the models that are directly attached to the model or the other models that are attached to the same unit. Go out and look at those models and say, you don't support the right interface. So what's really going on behind the scenes here, and how do we write code that makes these tests and notifies the user? So to introduce the concept, I'm going to talk to you about something that's very common that maybe you've never really thought about before, and that is the USB devices. This is a picture of cables of a USB device. And so I've got a couple different style of connectors. And I want to use this to describe how we do interfaces in Flames. These connectors have to conform to certain specifications, certain interface specifications. They have to be a certain size and shape. They have to contain certain electrical contacts to allow electricity to flow and pass in signals back and forth. And the internal electronics of the device have to be compatible with those electrical signals. Well, if you have a USB device and it conforms to this interface, it doesn't necessarily mean that it's going to work. This connector is only the physical interface of the device. And there's a whole bunch of devices in the world that support the USB standard for the physical interface. But a physical interface conformance alone is not all that's required. We also have to support what I call a functional interface. If I plug that device into a computer, it is going to, and it conforms to the physical interface, data is in fact going to exchange between the computer and the device. But is that data going to be recognizable to each side, to the computer and the device? That's only true if the right device driver gets implemented or gets installed on the computer to match this device. And the way that works is every USB device is required to provide certain information. It actually provides a vendor ID and a device ID. If that information, and I'll just use the device ID, if that device ID is known by the computer will go look it up and it will install the proper device driver. And once that's done, it's up to the implementer of the device driver and the implementer of the USB device, the device itself, to have both faithfully implemented a particular interface. There's not any further checking that takes place between the computer and the device. The device driver just assumes that the device has implemented a particular interface. And it starts communicating with that device, assuming that the device is implemented properly. We do something very similar to that in Flames. We took lessons from a very successful industry, and we said that's what we can do in Flames. So let's go take a look at the code and figure out how it is that those particular interface tests and error messages were generated. So we're going to go first and look at that ground vehicle model. So I'm going to go to Equipment, and I'm going to go to Platform, and here's the FEX ground vehicle model. And I'm going to look at its class initialization. And in the class initialize function for that model, there's this little call made right here, F entity add interface tag. So this can be any string that you choose, any arbitrary string, as long as it's a string that's going to be used by the model that uses this model. If there's multiple interfaces that you support, you can put a colon here and separate each interface by a colon. This is done for the default structure, which means that every instance of this class is going to have this tag associated with it, and just automatically every instance will support this interface. And that's all you have to do. This is equivalent to a USB device saying, "This is my ID. This is how I can be recognized." So now let's go to the cognition model where that interface was checked, and it was the ground vehicle driver. So we're going to go look at this configure on unit method. And when you go to the cognition model training videos, you'll understand about what this particular method is. So I'm not going to spend time talking about it now, but I will just show you what the test was. It calls, in this case, we call this function called set platform, and we'll talk about more about why we do it inside of this function. But I'm going to go to that function, and that's down in here. And what this function does is it calls one of the most common routines used to check an interface. Is it goes to the unit and says, "Give me the first equipment that supports a particular interface." And it says, "Well, what kind of equipment do I want? I want a platform, and this is the interface that it has to support." So if there is a platform model that's attached to this unit that supports that interface, it'll return a pointer and everything will be fine. If it's not, we'll get this error message right here, and this will return failure, which in turn will cause us to set this flag, and then we'll print this error message that this cognition model will not execute for this unit. So we'll go right back to what we had here before. We take this platform off, we hit accept, and we get that message. This cognition model will not execute for this unit. So that's where that came from. So this is how cognition models can check to make sure that the other models that are attached to the unit that were attached separately are models that this particular cognition model needs. So now let's go look at what that radar model did to check the data processor. So I'm going to go to the source code for the radar, which is underneath sensor, and it was the FEX radar class. And in the configure method, which we talk about in another training video, we go looked at the name of the data processor that was specified. If that name's blank, we bark because we have to have a data processor. If the name is specified is a data processor that doesn't even exist in the scenario, we bark. But then if we get a data processor, we then go check, does it support a particular interface? So here's the call, fentity supports interface, and that'll return true or false based upon whether or not that's interface is supported. So that's how we check it for the radar, and this is the message that we got when we put in a data processor that didn't support the interface. After that check is performed and this model is happy that the model that it needs that was specified supports the interface, or the cognition model is happy that there's a platform model that supports, or whatever the combination might be, whatever you as a developer decide you want the dependencies to be, the two models then start talking to each other as if each model implemented that interface correctly. They just assume, just like you do with a USB device and a device driver, that the implementers of the device driver and the USB device implemented that interface faithfully, and they start talking to each other that way. And that's exactly what the models here will do. So if one of the developers fails to implement the interface properly, then things aren't going to work right. But if you put that tag on there, that means that you have in fact implemented the interface. And if you refer to that tag, that means you're going to interact with that model in conformance with the interface. So where is the interface documented? Where's the specification that the developer of the sensor and the developer of the data processor can use to make sure that they're building their models in such a way that they're going to communicate? Well, you don't have to write a document. If you're the guy that's writing the sensor and you're the guy that's writing the data processor, and it's your code, you can just make sure that you wrote the code in a way that the code's going to be compatible. But if you're going to allow your model to be used by somebody else and by another developer, and you want to have your model be able to be interchangeable with other models, it's nice to have the interface documented. So we have done that for the starter models and the tutorial models. We have documented the interfaces. We have a document that comes with the starter content and the tutorial content that documents the interfaces that are used by the starter and the tutorial models. So here's all the interfaces right here. We'll go to the equipment model interfaces, and we'll look at the data processor interfaces and the F-Track data processor interface. Here it is. So it's got a bunch of descriptions of what records it's supposed to use and what queries it's supposed to support, and the actual methods that are referred to are talked about in another training video. So how you actually implement that is another discussion. But the interface is documented. So let me go now to the documentation of the tutorial content, the tutorial component. So here's the tutorial content documentation, and first going to go down to the equipment models, and we're going to look at that sensor model that we had. Let's go to the FEX radar, and down at the bottom of that documentation it says supporting models. So these are the models that are necessary to support the processing of this model. And it says here it needs a data processor and has to support that interface. So I can actually click on that and it'll just jump right back over to the where this interface was documented. And then I have so this says that this radar needs a sensor, that's a data processor that supports this interface. And then underneath the data processor, here's the FEX tracker. This documentation says this is the interface that I support, the FEX tracker data processor. So you can click on that and you go to the same page. Now in Flames, we have chosen to take the data types and the documentation that is for the interfaces that are used by the starter models and put them in a separate repository and make them have a life of their own, actually separate from the starter models. And what that will allow you to do is to write models that are compatible with those interfaces. And we've done the same thing then with the tutorial models. So the tutorial models and the starter models use the same interfaces. So it's generally a good idea to let the interfaces have a life of their own, not let them be class specific. They need to be out there so that other classes can see them and implement them. So that's the overview. It all gets down simply to these character strings that can be set with a class and can be checked with a class, just like the device ID on a USB device. And then it's up to you to make sure that somehow the specifications associated with that interface are implemented by both model, whether you want to document it formally like we have done here, or whether you just want to do it internally or whatever you want, or not even document it at all. You have to make sure. Even if you don't document it, it is important to check interfaces. You may define your own interface names, and so only your models use your interfaces, and you don't care about anybody else using them. But you still want to check the interfaces because you don't know if a user is going to take your model and try to attach it to a unit with other models that you didn't develop, and the models aren't going to work together. So you need to always set interface tags and check your interface tags whenever you have models that are interacting with each other, if for no other reason, just to make sure that nobody tries to use your models with other models that are not compatible. So if that's all you want to do, you just got to put a couple of character strings in a few places and you're good to go. Now, before I finish this topic, I want to talk about some of the other tools that are available in Flames to help end users make sure that they are specifying models that work together, that have interfaces that are compatible. So I'm back in Forge again, and I'm back looking at this blue sensor that I had defined. You might remember that earlier I took the name of this radar warning receiver data processor and I pasted that name in manually, and that's what caused the interface to fail. So I'll just do it again in case you don't remember. So I'll go back to the sensor and I'll take that name and I'll paste it in, and I'll hit accept, and it says nope, it doesn't support the interface, so the configuration failed. So I'll click on it again. I get back to what I had. So normally we don't have to cut and paste names like that. A lot of models have these little browse buttons on the side that allow you to browse for a particular name of an object that they can put in here. And there's also these little view buttons that will take you to look at the definition of the particular data processor that is specified. So I do that, and it just jumps right over to the data processor window and to the Blue Tracker data processor. So I can click on this list, this little browse button, and it pops up a list of data processors. But if you'll notice, there's only one data processor listed here, even though I've got two data processors defined in this data set. So why is that? Why am I only getting one data processor listed there? Well, let's go take a look at some code and figure out why that's the case. So I'm going to go back to my EXM radar class, and I'm going to look at the template file, and that's the template file that was used to define this user interface right here and specify that these buttons are supposed to be here. So I'm going to go to the template file, and I'm going to scroll down to the place where data processor is specified, and here it is right here. It's this field right here, data processor name, and next to it I have a little horizontal box with two buttons in it. I've got a button that is used to select the data processor, and then a button that is used to go view the data processor. And the way those buttons are implemented is with a real special, real powerful event that we can attach to buttons. And this is the typical thing that you'll find for any button. There's an event that says select. So you specified here what do you want to have happen when the button is selected. And then we say, well, we want a function to be called. And you just put the name of a function in your code, and that function is going to get called. So what we've done right here is we've picked one of the Flames off-the-shelf or built-in functions. It's a pretty long name. fentity manager gets selected entity by name, selected entity name by interface. So you can go look this up in the documentation. This particular function will automatically put that window up. And it says we want to get an entity from the data processor manager. We are going to take the name that is selected, and we want it to be pasted into a field in my user interface of this name, which is this field right here. And then we specify this optional argument that says, and by the way, we only want you to list in this window that pops up the data processors that specify that support this particular interface. So it gives the end user a really convenient way to enter that value there, and also make sure that if they pick it from this list rather than typing it in manually, they're going to get a data processor that supports the right interface. So that's one of the tools that we can do. Not only do we bark when the user puts in a wrong value, we do a lot to help the user make sure that they don't enter the wrong value in the first place. So that's a built-in capability in Flames, and that you can put these buttons on your template files and specify any particular user interface that you want. So now let's go look at another place where we can do something similar. We can help the user make sure that they are composing things correctly. And for that, we're going to go over to the units window. And remember, we have these two cognition models attached right here. Well, this particular cognition model supports several commands. And we'll go over to the commands tab, and we're going to add one of those commands. These are the commands that are definition commands. And one of them is use formation. So this is this use a specified formation when leading a formation of ground vehicles. So that's what this command does, and I have to specify the name of a formation. So it says the name of a formation to use. The object must support the FBasic formation interface. So it's specified right here that the user has to do that. Well, he could go look at documentation that we just pulled up, see which particular formation model it is that supports that interface. But we have a tool, built-in capability to allow the user to pick the right formation. We will just double click on this. We'll get a list. We'll pick the formation that's in there, in that list, and you'll notice we're not getting any kind of error message right there. Well, I'm going to go back and look behind the scenes. If I go over to my formations window, I actually do have two formations listed. One of them is named Maritime Formation. It's a different class. And I'm going to grab that guy manually and go over to my units window. And I'm going to paste that name in there. And as soon as I click somewhere else, it immediately turns red. I don't really know yet why it's red, but the command turns red because it's got a name in there. That formation actually exists. Why is it red? The reason it's red, I hit accept, and it tells me the formation does not support the FBasic formation interface, which is what the comments say it has to do. So what do you do in your code to make sure that the formation or the name of another object that you're referencing one of your commands, whatever that object might be, actually conforms to the right interface, and that the user is assisted in making sure that they specify an object that actually conforms to that user, to that particular interface. So I have opened the model prototype editor, the Flames model prototype editor, for the prototypes for the commands that are defined by the FEX driver cognition model. And in the cognition model developers tutorial, you'll learn about model prototypes. So here's a prototype for the command, the use formation command, that command that I see right here in this window. So I'm going to push this over to the side a little bit and just give you just a really quick correlation between what's in this prototype and what's on the window. So it says this is the process method that I'm going to use right here. This is the class that I belong to. This is the description of the command, and that's exactly what shows up in the window right here. This is the input that it has, formation. This is the description of the input that should be displayed in the window. So you see that right here in the input description, the name of the formation to use. But you'll notice that it doesn't actually say, and we didn't actually type in, the object must support the FBasic formation interface. So how did it know to write that in there? And then how did it know to make sure that only an object that supports a particular interface is entered there? Well, in the definition of this particular input, I have all different kinds of data types that I can specify. And the one that I've chosen here it's an entity. So I want the name of an entity object to be specified. And there's a bunch of different entity classes. So I want it to be a formation. And then I went down here and said, and I want to make sure that this particular entity formation object that gets specified supports this particular interface. So I just typed that name in there. When I do that, it does a couple things. It first automatically adds this to the end of the description so that the end user gets a little bit of extra help knowing that it has to support a particular interface. It's something that you don't have to worry about writing and making sure it's kept up to date. But even more importantly, because I've said I want a formation that supports that interface, when I go over here and double click on this or click on the browse button, it only lists the formation. So it's only formations that are listed, and only lists those that support the interface that I specified. So you'll learn more about defining prototypes for commands in the Cognition Model Developer tutorial, but I just wanted to point out the way that you can specify interfaces. And the point of this is to help guide the user in making sure that they're assembling a unit and specifying inputs for it and composing it and in ways that allow the models to work together the way they are designed to work, that the models conform to the interfaces. Well, it's a pretty long video, but it's actually a pretty exciting topic. It's very, very important, as I mentioned before. This is a key thing to allowing you to create simulations that your users will be able to use easily, and also make sure that your models are going to work with the models that are attached to the unit. So thank you very much for listening to this whole thing, and I sincerely appreciate you choosing to use Flames.